Does physics help us to understand the world? Unsurprisingly, the answer is it depends on what you mean by understand. If by understand you mean to get a commonsensical, everyday picture of how things work, then it only helps you to understand the part of the world to which commonsensical, everyday pictures apply. The human mind has a series of ways that it understands things to be built up intuitively. When I think about the world commonsensically, I imagine that the world is made out of stuff. If we were Immanuel Kant, we could come up with a definition of what stuff means. But it's probably like something that occupies space. It's got a shape. It's got a sound. It's got color to it. But in fact, we know that a lot of the universe does not have these properties, and this whole notion of things, which then have properties, is probably going to kind of break down. The notion of color, for sure, is not applicable to everything. Color is a phenomenal experience that I have, which is associated with certain wavelengths of light. The Bohr radius gives us a sense of the scale of the hydrogen atom. Subatomic particles are going to be smaller than the wavelength of light. I'm making pasta. So subatomic particles are going to be smaller than the wavelength of light, so it doesn't really make sense to talk about them having color as an attribute. That doesn't stop me from imagining electrons as yellow for the simple reason that I don't know how to imagine something which doesn't have color. I imagine that an electron exists at a point in space, even though I know intellectually from quantum mechanics that, it doesn't exist at a point in space, certainly in the way that this thing of red chili powder existing at a point in space. What can we make of this? If I want to represent the pasta that I'm making right now, I can represent it successfully in terms of something that exists, has a certain temperature, it has a volume. I can represent it in terms of these concepts, and I can understand it. I can understand why when I put my fork into it and I move it around, noodles behave in the way they do. I can't use these same concepts to describe an electron. So what do you describe an electron as? A state vector in a Hilbert space, or better yet, as a density matrix? What are these things? What is a state vector in a Hilbert space? I imagine a vector as literally like a little arrow in some space pointing somewhere. This is an imperfect analogy. This is not what it really is. What it is to be a vector is to satisfy certain criteria. Quantum mechanical states can be represented as vectors because the states relate to each other in a certain way that satisfies the axioms of what mathematicians tell us is something we get to call a vector. And it has a certain analogy to arrows in 3D space, but it's an imperfect one. It's not always going to hold in all respects. Mathematics is not the study of numbers, it's not even the study of shapes. Mathematics is the study of structure qua structure. Make up a set of concepts, invent some structure that relates all those concepts to each other, and you've got mathematics. You don't even have to have an idea of what those concepts mean beforehand. You just make up concepts as placeholders and then invent a structure for them. And that's enough, because then what it is to be that concept is to be the thing that fits into your structure. This is, I think, what people mean when they sometimes use the word formal to describe this kind of thing. You have defined away the content by saying content is form. It's as if you have a network of nodes all connected to each other, except you don't even have the nodes because the connections are the set of how each node could relate to all the other nodes, and that is sufficient to define each node. The node is nothing but the thing that exists at the intersection of the connections. And what physics is, at the end of the day, is taking experience, qualia, mapping them onto the most abstract form of structure you could have, doing something with that structure, and then mapping it back to qualia. What is it for time to pass? What is it for change to occur? Well, it's that. But in quantum mechanics, it's a unitary operator. It's some abstract thing. Why is it a unitary operator? Because a unitary operator meets certain criteria, and those criteria are the sufficient criteria that you take the current state of the universe, you map it into abstraction, use a unitary operator to go forward into the future, get a new representation, and then you map it back and you say, this is what in the future things are going to be like. I can explain to you why the water in this pot of pasta stays in it, and you can understand that in some sense that is very intuitive. If I want to understand why the energy levels of the hydrogen atom are what they are, it will be a very tenuous kind of understanding. And that makes sense because our brains are similar in size and energy scale and time scale to a bowl of pasta, much more similar than they are to a hydrogen atom, or to something very large, or something which endures over a very large time. As you move away from the scale of the human brain in space and time and energy, the understanding becomes much more tenuous and abstract. One thing to consider is the abstract structures that we use in mathematics work so far, but they also exist in a brain. To me, it seems that there's no reason to suppose that mathematics will continue to work if you move even further away from the scale of the human brain. In fact, I think you can already see this happening with some kinds of questions. If you consider the question, why is there something rather than nothing? I think the fact that the answer is not obvious can obscure the fact that it's not obvious what an answer would be. Like, what kind of an answer could be an answer to that question? Think about reasoning itself. Reasoning is the process of starting with some knowledge and moving to other knowledge. Where does that new knowledge come from? I tell you, all men are mortal, Socrates is a man, therefore Socrates is mortal. Is that conclusion somehow contained fully within the premises, or have I come to something truly new? What kind of an answer could be an answer to that question? Maybe all I'm doing is just pointing out difficult questions, or obtuse ones, or ill-formed questions. But maybe in some way what it is to be an ill-formed question is to be at the edge of the scale where thought structures are applicable. I may not understand understanding, but I do understand that these noodles look pretty good.
Heisenberg and Bohr were drinking poppy tea. I swear last night I fell asleep in my van, and now these guys are pouring one for me. I swear last night I fell asleep in my van, and now these guys are pouring one for me. And now these guys are pouring one for me.